Hey everyone, this week we're going to work on calculating the volume of some 3D figures. So for some of the problems, I'm going to help you kind of walk through the whole problem. For other ones, I'm just going to give you some hints. So we're going to get into our week 7 practice problems using volume formulas. The first problem says that an automobile engineer is redesigning a conical chamber that was originally specified to be 12 inches long with a circular base of diameter 5.7 inches. In the new design, the chamber is scaled by a factor of 1.5. And then we're going to find the volume of the original chamber. And then we want to determine how much less volume we have with the original for the original as compared to the new one. So for this, we have two concepts going on. The word conical here means we're talking about a cone. So one thing we need to do is calculate the volume of the cone. And then we also have the concept of scaling something. So when we scale it by a factor of 1.5, that means we're going to increase it or make it bigger by 1.5 times. So we have a cone. It has a diameter of 5.7 inches. So in order to find the radius, we need to take 5.7 and divide by 2. And then it says the length of the cone is 12 inches. So that is essentially going to be its height. So the first concept here is the volume of a cone. The formula for that is 1/3 times pi r squared times h. So that's our first concept. So if we know the formula, we are going to just take our value for r, you can calculate that, put it in our formula for r, and then our h here is going to be 12. So this is very simple to do. However, in this problem, for some reason, when they were calculating the answer, they alternated between using pi, like actually putting pi in your calculator so you get the full number. They did that sometimes, and then sometimes they just use 3.14. And when you change between those two, it will change your answer down in like the hundredths range, which is what happened on this problem. So I'm going to show you a slide that I have added into the week 7 problems and see if I can try and walk you through this problem. It should be a very simple problem, but now it feels very complicated because of their interchanging the pi and 3.14. So now we're gonna go to the computer and I'll show you what I did. Okay, so this is the problem. I inserted a page after this. So for what I just did on the whiteboard, I said when you calculate the volume of the cone, for this part of it, you want to use 3.14. Don't put pi in Desmos. Just use 3.14. Plug your other values in. You should get 102.0186, and then that rounds to 102.02. So that will be your first answer. The next concept in this problem comes from this sentence here. In the new design, the chamber is scaled by a factor of 1.5. So if we scale that by a factor of 1.5, we can calculate the new volume. So for this cone, we are going to scale it by 1.5. Whenever we scale volume, that K, that represents if it's 1.5, we would put 1.5 there. If we say we're doubling it, we would put a 2 here. But whatever we're scaling it by, then we cube it. So for this problem, we're going to take 1.5 and we're going to take it to the 3rd power. So that means we end up with 3.375. At this point, all you do is you take your original volume and you multiply it by this 3.375 in this case, and that gives you your new volume. So the question asks, what's the difference between the new volume and the original volume? So what you do is just take this new volume and subtract the original volume, and it will give you your answer. So the problem in and of itself is not complicated. However, because of this whole pi and 3.14 thing, I need to explain to you when to use pi and when to use 3.14 so that we can get to the answer that they have as the answer. So we're going to move back to the computer so I can show you that. Okay, so when they calculated the scaled volume, they essentially recalculated the original volume. I'm not really sure why they did that. So here, this calculation here is the same thing that we did before, except when we did it the first time, to get 102.02, we had to use 3.14. Here, we have to use pi, like use the actual number for pi. So that makes our original volume 102.07 as compared to 102.0186. So here is our original volume. That's what we're going to use. We're going to multiply it by our scaled number here. And then this becomes our new volume. So I kept all the decimals. So now we want to find the difference between the new volume and the original volume. So when they calculated that, they used this new volume and then they subtracted the original volume that was using 3.14 rather than this one over here. Okay, so this finds a difference. This is our new volume, this is our original volume. That's the difference, and the answer is 242.47. If you need to watch this part of the video again, feel free to do that. I tried to put all the calculations in here. That's the first answer right there. That's how you get the second one, so that you kind of have it in front of you. But watch it again if you need to. I'm sorry, I think that became more complicated than it needed to be, but I also didn't want you to sit there and be frustrated because you couldn't come up with 242.47 if you were consistent, either using pi or 3.14 for everything. You wouldn't get that answer. All right, so we'll move on to number 2. Problem number 2 says a conical container can hold 120 pi cubic centimeters of water. The diameter of the base of the container is 12 centimeters, and then what we want to find is the height. And then they also tell us if the diameter and height were both doubled, the container's capacity would be how many times its original capacity. All right, so conical, we know we're dealing with a cone. For this one, they give us the volume. It's 120 pi, and they give us the diameter. And so first thing we're going to do is find the height. Okay, so we want to use our volume for the cone again. V is equal to 1/3 pi r squared h. They tell us the diameter is 12, so that means we know that the radius is 6. For this one, they told us the volume. It is 120 pi. So go ahead and plug that in where the V would be. And then we're going to set that equal to 1/3 times pi. We know what r is, so we put 6 squared. And then what we're going to solve for will be the h. So at this point, you're going to want to multiply these things together. If you want to leave the pi's just as pi, when you divide, they should cancel. But at this point, it's just algebra. You're going to solve for h. The next part of the problem says, if you were to double the dimensions here of the diameter and the height, what times the capacity would your new volume be? So that's a scaling question again. So if we remember how much we're going to increase it, we call that k, and then we're going to cube it. So in this case, they said they're going to double everything. So that means that 2 would be your k, and then we would cube it, and then you can finish that off to finish up the problem. All right, number 3 says the volume of a sphere whose diameter is 18 centimeters is so many cubic centimeters. That cubic is telling you you're finding the volume. And then it says if its diameter were reduced by half, its volume would be blank of its original volume. So now we're dealing with a sphere, and the first thing we want to do is calculate the volume. So we'll go ahead and do that. So for this, we need the volume of a sphere. The volume is 4/3 times pi r cubed. They tell us that the diameter is 18, so that means we know our radius is going to be 9. So to calculate the volume, you're going to go ahead and just substitute in your 9 for the r and just calculate to get that volume. So that's the first part of the problem. The second part of the problem says that if we scaled everything or halved it, they want to know how much is it going to increase. So this is another problem where we are taking the k to the 3rd power. Here we're going to take everything and cut it down by half. So that means our k is actually 1/2, and we're going to cube it. So I'm going to go ahead and finish this one with you just so we make sure we remember our exponent rules. When we have a fraction, we are going to cube what's in the numerator and cube what's in the denominator. So this essentially becomes 1 cubed over 2 cubed, and then when we reduce, that ends up being 1 over 8. So that would be 1/8. All right, so those are some helps and hints for problems 1 to 3 on your practice problem slide.